Welcome to video clip 2.2, in which we discuss process activities. In the definition of a business process, we learned that a business process consists of a set of activities. So what is an activity? Activities are units of work that require time to be performed. In this week we only cover tasks. Tasks are atomic activities. These are activities that do not have an internal structure. Or from the modeling perspective, we are not interested in the internal structure of tasks. In order to look at the various concepts that BPMN has to offer, we propose a sample scenario, and that is an order fulfillment scenario. We always have, let's say, a little text that describes this scenario, and afterwards we will use the concepts of the BPMN to express what we've seen in the text in a process model. And we start, of course, with activities. So the sample scenario is as follows. The process starts by entering the details of an order in an IT system. The ordered product is obtained from the warehouse, packaged and shipped to the customer. An invoice is sent to the customer. Upon receiving the payment, the order is archived. So this is a fairly typical textual representation of parts of a business process in which we can find a number of activities. So let me just try to highlight some of them. So we need to enter the details of an order in an IT system. Then the ordered product is obtained from the warehouse. It is packaged and shipped to the customer. Then an invoice is sent to the customer. A payment is received and the order is archived. So from the text we can derive the activities that are relevant for the process. And then what we can do is we can just use the concrete syntax that is provided by BPMN for activities, which is the rectangle with the rounded angles, and specify a label that describes the activity from a semantic point of view. So what actually happens during the activity. And here we have these 1, 2, 3, 4, 5, 6, 7 activities on the process. And what we did is, from a textual representation, we came up with a model representation which is very simple and which is just part of a business process, but at least it's a start. Activities are performed in coordination. This is also what we learned from the definition of what a business process is. So the activities are not executed independently from each other. There are execution constraints. And a simple form of execution constraint is sequence flow. And sequence flow, of course, means one activity can only be started after another activity has been performed. And the notation we use for this is a directed arc between activities, more general, between nodes in the process model. And of course, arrow B means that B can only be started once A has been terminated. All right, and after A has been terminated, the sequence flow arc is signaled, telling B that it is now ready for execution. That is how it is handled. And using the sequence flow, we can now come from the process model that had just activities to a process model that also has sequence flow and that is able to express that these activities are performed in coordination, so as a sequence of activities. All right, and of course what happens here is that first the order details are entered. After the order details have been entered, this sequence flow edge is signaled. So we can think of a signal on the edge, and the signal is then brought, let's say, transferred to the next activity, which is the obtained product from warehouse activity. Once this activity is signaled, it is started. It can be started. It's ready for execution. And once obtained product from customer is terminated, the outgoing sequence flow edge is signaled, so that at the end of the day all these activities have been executed in the right order and all the sequence flow edges have been signaled. We were discussing process models and process instances. We were mentioning that each process model can have any number of process instances. And we now dive into what a process instance actually is. And a process instance consists of activity instances. These are concrete executions of activities in the organization. The concrete ordering of a particular order, of particular order details, obtaining particular products from a warehouse for this process instance, packaging a certain product, and so forth, as specified here in this process model. Each activity instance traverses a series of states. We have also seen this in the previous example where we said, well, the first activity that can be executed is enter order details. That's the first activity that can be executed. When the order arrives, this activity is in the ready state. It can be executed. The others cannot be executed. They are not yet in the ready state. Once an activity is in the ready state, it can be executed, it can be running, it can be performed. So this first activity instance can then be performed. At that point, the second one can still not start because it waits for the first one to terminate. Once the first activity has terminated, the second one can start. It can enter the ready state and can then be executed. So we see that all these activity instances we have here traverse a series of states, starting from initial, going through terminated state. We'll have the states here in a bit more detail. So the states of an activity instance are as follows. First, an activity instance is in the init state. That means it is initialized, but it is not yet ready for execution. Then the activity instance can change state to the ready state. In this case, it is ready for execution. It can be started. If it is ready, it can be, or when it is started, it is in the running state. After it finishes the running state, it comes to the terminated state, and there is also a state called skipped. In this case, an activity instance is no longer required for a particular process instance. So let's try to sketch the states of an activity instance and start with the init state. So this is the first state that an activity instance is in. And when this process starts, or when the process is created, then all the activities are in the init state. We have seen when the order arrives, then the first activity can be performed. So can be performed means it enters the ready state. So that there is a state transition. What I'm now drawing is a state transition diagram. This is a graphical representation of the states activity instance can be in, and also of the state transitions. All right, we also discussed already that an activity instance which is in the ready state can be started. When it is started, it enters the running state. And after it completes running, it comes to the terminated state. All right, so these are the major state transitions that all these activity instances of a process instance walk through. First of all are in the init state. The first one gets ready, the first one gets running, the first one gets terminated. Then the second one changes from init to ready to running to terminated and so forth. So what I was drawing in the previous slide was not the complete lifestyle, not the complete state transition diagram for activity instances. Here is a simple diagram also taken from the BPM book. Here, like in the previous slide, the states of an activity instance can be represented by a state transition diagram, states and transition, of course. The states and their transition are an essential part of the semantics of a process model. We can only understand what a process model means if we know about the states and the state transition that the activity instance can take. All right, so here we have the same states we had before, so init, ready, running, terminated. In addition, we have the skipped state. That means it might turn out that a certain activity instance is not required for a certain process instance. In this case, it is no longer required, and therefore it can change from the init or ready state to the skipped state. And in order to represent that, we have these, let's say, composition of the init and ready state. And from this composition, there is a I will try to more highlight that Here we see the composition of these two, and the transfer from this state, from the not started state to skipped, is then possible from init and ready, and therefore we have this not started state around it that makes it simpler in the presentation, and it saves basically one arrow to the skipped state. I also like to mention that this state transition diagram is a simplified variant of the standard bpmn activity state transition diagram, but this simplification suffices for the purpose of our course. Right, so the example, I think, mainly went through all the material in this example related to activity state transitions of activity instances. So basically all of these activities that we have here, all of these activities, enter order detail, obtain product from warehouse, and so forth, they they start in the init state, they go to the ready state, they go to the running state, and they go to the terminated state. So they have these sequential state transitions from init to terminated. And when the whole process instance is completed, then all of these activity instances have then terminated. Coming to the modeling guidelines of activities, it's very important to model or to label activities correctly so that your colleagues will understand what you mean by this activity, what type of activity and what business activities, let's say, are represented by a certain process activity. And in order to do that, we should label activities in the verb-noun style, and we also need to use a consistent vocabulary. Okay. To motivate this, the verb-noun style indicates an activity, for instance, package product. Package product is verb-noun style, because we package the product. The same noun should also be used throughout a model if it refers to the same domain concept. So we've seen process models in which there are activities related to clients, and further other activities refer not to clients but to customers, but they mean the same entity of the real world. So you should use consistent vocabulary and either use customer or use client in this context. Consistent vocabulary should also be used across models, and we can use a glossary of terms of an organization to do that. So there are process editors, including also the Signavio process editor, that you can use that provide a glossary so that when you label an activity, you are proposed a number of labels that are, let's say, specified and documented in the glossary of the system, so you will not end up with problems like the one I was mentioning before. So far, when looking at a task, in the bpmn model, we just have the label that specifies what the task is about. bpmn provides additional information, additional also graphical information that tells us a little bit more about the activity, and that is task types. We can associate types to tasks. So a task can be of a certain type which characterizes the task further. Task types are represented by markers in the upper left corner of the task. So we have here a number of maybe the most important task types that are provided by the bpmn, which is the message task. Here we see we have two variants of that. We come to the difference in a minute. And this envelope symbol should tell us that these activities deals with sending or receiving a message, sending it to a partner and receiving it from a partner. If there is this pictogram of a person, then it is a user task. So the task is conducted manually. And when you see this symbol of this that you see here, it is a service task. That means the service is executed automatically. Task is carried out automatically, for instance, by software. When you have software, we use, when we have a task that is implemented automatically by software or by a software service, we use the service task for this. In our example, we can enhance the process model we had so far with the task types. So the first 3 activities are user tasks. We see that enter order details is a human activity, so a user does that, of course using a system, but the user is in charge of them, needs to do something. Then we have send tasks, so message task of the sending type. So whenever we have a task type, or whenever we have a task with a message marker, and the message marker is solid black, then that means we send a message. And when it is not black, when it is white in the internal, it is the receive task. So we see here that the task major activity, what happens here is the receiving of a task, or the receiving of a message, or the sending of a message. And the archiving is an automatic, or is a service task that is carried out automatically. We use the marker for the service task. We see and we get the feeling that BPMN provides a lot of information that we can visualize in the process model, but there is still more that BPMN provides. And this is done by a concept called attributes. So BPMN uses attributes to store additional information. So the whole diagram has attributes, but also each individual element has attributes. And what I just told you, these task types are actually stored as attributes and also have a representation as an attribute. More general, attributes hold additional information of BPMN elements. And not all attributes have actually a visual representation. So we've seen, so far we have just looked at the visual representation, but there are attributes in BPMN, and we come to that a bit later, that do not have a visual representation. So we can say when we take a look at a process model, we don't see the complete process model, we just see a visual representation of the process model. And there's additional information which is stored then in the attributes. Right. Another thing that is provided by BPMN is annotations. So sometimes you need to express more information and you don't have a nice place in the attributes or in the concepts provided by the language. And in this case, you use annotations to improve the understandability of business process models. The models can be enriched with annotations. And annotations can be attached to any model element and can be used to describe this model element in more detail. It's worth mentioning that annotations do not have any execution semantics. So we cannot specify execution semantics like providing decisions, providing, let's say, activities to stop and wait for input or something like that. Using annotations, it's just for documentation purposes. But still, this is important since the main, let's say, goal of process modeling is providing a common understanding among the stakeholders in a process management project. All right, here we have a little example where this activity, obtain product from warehouse, has an annotation, and the annotation says this activity assumes that the product is available in the warehouse. So there is an assumption that would be otherwise implicit. It's now made explicit in the model as an annotation in which, let's say, provides more information about this process. All right, we come to the conclusion of video clip 2.2, in which we discussed process activities. We looked at activities as units of work that take time to be performed. We introduced an order fulfillment scenario, just a very simple form, just a sequential flow of activities. We looked at activity instances. We learned that activity instances can have states. At each point in time, an activity instance is in exactly one state. Activity instances can have state transitions. Normally they go from init all the way to terminated. We looked at modeling guidelines related to the labeling of process activities. And finally, we investigated task types, attributes of BPMN, and annotation as additional means to provide information to process models.